In this video, we are going to work on generating equivalent expressions, and we're going to focus on factoring expressions. So my first problem here is 20 plus 8, and I want to factor the greatest common factor out of there to write a distributive property expression. So here, my factors of 20 are 1, 2, 4, 5, 10, and 20. My factors of 8 are 1, 2, 4, and 8. So I want to look for the greatest common factor of 20 and 8, and that looks to be 4. That's the biggest number that goes into both of those. So I put my 4 here, and here again, my greatest common factor that goes into both 20 and 8. So using my area model here, I know that I take 4 and I multiply it by some number to get 20. Well, 4 times 5 is equal to 20. And then my 5 would go down here. And then I also want to know 4 times what is 8, and that is 2. And so then my 2 would go down here. So when I write my expression, it would be 4 times 5, which I get from right here. Put those in parentheses. And notice that I'm adding here. And then again, parentheses. And then here's my next one, 4 times 2, and parentheses. So here it says to rewrite this expression here using the distributive property. So I know that when I use the distributive property, I am distributing or handing out the same number in my problem. Well, in this problem, I'm handing out or distributing this 4, or my greatest common factor, to 4 times 5 and 4 times 2. So that means I would put my 4 here, and then I put my parentheses. My first number here is 5. And again, it's an addition problem. And then my second number here that I'm multiplying by is 2. So then I would put my 2 here and my parentheses. This problem, I'm going to factor 18n plus 54. So this time I've got to keep in mind that I have this variable here. So first of all, my factors for 18 are 1, 2, 3, 6, 9, and 18. And my factors for 54 are 1, 2, 3, 6, 9, 18, 27, and 54. So again, want to find the greatest common factor for 18 and 54. And that looks to be, like, it is 18. So write my 18 here. And that 18 is going to go here for my greatest common factor. And again, I want to see 18 times what is going to give me 18. And that would be 18 times 1. But again, in this case, I've got the variable, so it's going to be 18 times 1n. This 1 is going to go right here, along with my n. And then when I go here, I want to see how many times 18 can go into 54. Well, that would be 3 times, so it'd be 18 times 3. And so that 3 again would go right down here. And again, back to this 1n. Remember, if I just have 1n, that is just equal to n. So now I'm going to write my expression. And so, like I did before, I'm going to take this. So I'd have 18 times my n in parentheses. And again, it's an addition problem. And then my 18 times 3 with my parentheses. And again, I'm going to rewrite this expression using the distributive property. So I distributed the greatest common factor into my problem. And again, that number is 18. So I would have 18 on the outside with my parentheses. First thing I multiplied by was n. So I put my n here. Second thing I multiplied by was 3. And again, it's an addition problem, so I would put plus 3, parentheses. take a look at this problem. I have 7m minus 28. So again, I want to look for the factors of 28, or excuse me, 7, which would give me 1 and 7. And then I want to look at my factors of 28, which are 1, 2, 4, 7, 14, and 28. Again, my greatest common factor would be 7. And so when I write my expression, I'm going to put 7 times some number. Again, this one's subtraction, minus 7 times another number. Again, this first one is 7m. So if I've taken 7 as a greatest common factor, 7 times what gives me 7? And that would be 1, and the m comes along with it. So it would be 1m, or like we can write it as 7 multiplied by m, minus 7 times what gives me 28. And when I do that, that would be 4. And so now, again, I want to look at what was my greatest common factor, and that is 7. So I would put my 7 here, parentheses. First thing I multiplied by was the m. And again, it's a subtraction problem. And the second thing I multiplied by 7 was 4. So using the distributive property, it'd be 7 times m minus 4. So let's take a look at this problem. 9w plus 12. So if I factor out my 9, I have 1 times 9, or I have 3 times 3. If I factor for my 12, I would have 1 times 12, 2 times 6, or I'd have 3 times 4. And I look for my largest number that they both have in common. That would be 3. And so when I write this as a distributive property problem, I'd have my 3 on the outside, my parentheses. Well, 3 times what gives me 9? Well, that's 3. And I have a W along with it, so that'd be W here. It's an addition problem. And then 3 times what gives me 12? And that was 4. And I can check it by saying 3 times 3 is 9W. And then 3 times 4 is 12. And I have my addition sign here. And since this is the same as this, I know I've done it correctly. So if we take a look here, I know that I have 4 multiplied by 15 gives me 60. I know that 4 multiplied by 4 gives me 16. So I know that 4 is my greatest common factor. Put the 4 on the outside here. My parentheses. Well, I know that 4 times 15 gives me 60. Again, I have the S there. It's an addition problem, so I put addition. And then I know that 4 times 4 is 16, so I would put my 4 here. And I can check it by saying, well, 4 times 15, that is 60S, plus 4 times 4, which is 16. This is the same as this, so I know that I have worked out the problem correctly. Here I have 12 and 20. Well, I know that 4 multiplied by 3 is 12. I know that 4 multiplied by 5 is 20. So my greatest common factor is 4. So again, I put my 4 here, parentheses. 4 times 3 gives me 12. It's addition, so I put plus. 4 times 5 gives me 20. And again, the m is there, so this would be m here, and my parentheses. And again, I can check 4 times 12, or excuse me, 4 times 3 is 12, plus 4 times 5 is 20, and it's 5m, so this would be 20m. Next, I have 15y plus 9. So I know that 3 times 5 is 15. I know that 3 times 3 is 9. Greatest common factor is 3. My parentheses here. I know that 3 times 5 gives me 15. And again, the 5 has the y with it. It's an addition problem. And then I know that 3 times 3 gives me 9. And so then I can check. 3 times 5 is 15. And again with the y. Plus 3 times 3, which is 9. So again, this is the same as this. So I know that I have done this problem correctly.